This section heading is called Abusing a Stateless Firewall. So what we're going to do in this section is we're going to demonstrate how a stateless firewall is going to allow a client on the outside to send some erroneous traffic through it. The way that we're going to demonstrate this is by crafting a SYN packet and having that as the initial means of communication to the web server on the other side of the stateless firewall. So now the significance of this is if we take a look at the three-way handshake. So a SYN packet should only be a response message from a server. So a client should never initiate with that type of packet. So again, it's erroneous traffic. So now the significance of this is that a lot of attackers in the past, what they've done is they've done things to actually confuse the devices. And again, we're just demonstrating that this should never happen, and that the stateless firewall is actually allowing it to go through. So now the way that we're going to do this is we're going to craft our own packet. We're going to do this using a Python module that's known as Scapy. So if we type Scapy, this is going to put us into interactive mode with the Python interpreter and load all of the modules necessary for Scapy. So now Scapy, as a part of those modules, is going to have some predefined protocols, and we can view those protocols, or the list of those protocols, with the ls function. So if we type ls, we can see that long list of protocols. So now these protocols are classes defined within Scapy modules. So we're going to be, when crafting our packets, we're going to be taking a look or using two protocols within here, TCP and IP. Now I'm calling them protocols, and just like we would envision with the protocol, is we have headers and trailers depending on which protocols you're talking about. Now when referring to TCP, we just have a header. So we have our protocol header, and then the way that we envision our protocol headers is that we have fields within them. So these are used for our communication, right? So when crafting our SYN packet, we're going to be adjusting the values within the control bits down here. So you can see over here, this S represents a SYN, and then over here we've got the A, which represents an acknowledgement. So we've got synchronize, SYN packet, SYN ACK. So it's going to have both of these, the S and the A, the ones bit in those, or the bits lit in those values over there. So now inside of here, inside of Scapy, how are we going to define those? So we want to see within each of these classes, both TCP and IP, we want to take a look at those header fields, right? So we're going to refer to these as variables because we're going to essentially assign them. So if we want to view them, we're going to pass them as an argument to the ls function. So over here, we're viewing for IP, and we can see the header fields for the IP header. And then if we want to take a look at the TCP header fields, we can see it right here. Now I'm showing you two ways on the site intentionally. You can view these values inside of here, but you can also use them or view them by appending .show. And the reason that I'm showing you both ways is because they represent things differently and sometimes show you different values. For example, up here, it's telling you that by default, the flags field is set to 2. So this may not be apparent to what the 2 means. Okay, we can see over here 1, 2. Maybe that's what it means. Or if we use the .show to show the current settings for our variables, we can see over here that that 2 represents the S. So we've got a SYN packet. So that's what we have at our layer 4 TCP header is set by default. It's a SYN packet. So we're going to need to alter this. Now the way that we're going to define these variables is, if you take a look up here, we've got the variable name, we've got the assignment operator, and then the value. So the way that we'll set these is by passing them as arguments within them. So for example, if we want to set, and let me just show you the IP.show. we can see over here that the variables by default are set to localhost. So we're going to just, as an example, let us define this variable. So destination equals, and we're going to set it to our web server. And then we'll use .show to show the current state of it. So we can see over here that we define that variable. Now, by default, it also adjusted the source. Now, we're going to keep this to actually represent us. Obviously, if we're doing other sort of things with Scapy, we might want to change that. And we can easily do that within there as well. Okay, so we're seeing how we can adjust that. Now, when crafting our SYN ACK packet, we're going to need to satisfy two layers within Scapy, layer 3 and layer 4, TCP and IP, which is essentially the focal point of the internet. Anyways, so we're going to use a function when actually sending this packet. Now, Scapy has a long list again of predefined functions, and we can view them with the lsc function. So if we type lsc, here are all of your functions. Now your functions are to perform some sort of task or operation, and if we look over to the right, it tells exactly what that is. So we can see over here we're going to be using this sr1 function, and it's going to send packets at layer 3 and return only the first answer. Now that's the reason why we're not adjusting our source IP address, because we actually want to get that answer to verify that we're communicating through that firewall. So we're going to do it here, and we're also in a second we're going to go over to Alice's station and verify that which rule it's actually matching. Okay, so when you're dealing with functions, you need to see what, if any, or how many arguments can be passed to it. So we're going to use the help for this, and inside of here we'll pass the function name, so sr1. This will open us up to the documentation for that function. We can see over here that we've got sr1, and then we've got some things over here that we can pass, define and pass to it. We can also see the default values for those variables inside of there. Okay, so let's type Q to quit showing the documentation, and now let's actually craft and send our packet. So we're going to say sr1, and then inside of here we're going to need to define the destination. So we're setting the variable there, 10.10.1.112. So your protocols act as payloads to one another. So we're going to have TCP down here, and then TCP, we need to adjust the value of the flags field. So flags, and then inside of here, it's going to be SA. Now we have to close out the function, right? So open, close. Now we're going to hit enter here, and we're going to wait to see if we get our answer, and we do. All right. So now we're verifying that we're communicating here, and we're going to type quit to quit out of interactive mode. It will return us to a prompt. And now we'll go over to the Ubuntu end station. So now back on our Ubuntu end station, we can verify that the packet was allowed to pass through the stateless firewall. We know this anyways because we actually received an answer from the destination host, which was our web server. Now when defining our rule, the reason that it was allowed to pass through it is because A, it's a stateless firewall, and we'll see what that means when we take a look at a stateful firewall. But A, it was a stateless firewall. We matched what the criteria of the rule. So the rule says, look, if the source is coming from anywhere and it has a destination address set to this host, which we did, and then also over here, it just has to have a destination port of either 80 or 443. Now, we didn't define the port, but if we take a look at what the default value for the destination port was at TCP, we can see it's HTTP, which is 80 by default. If you actually did or passed this as an argument to the ls function, you would see that it would represent that as an 80 rather than HTTP. But if you know the default port for HTTP, then you would know that it was 80.